Can you guys hear me? Good morning. This is Mr. Sean from YATJA, and welcome to the last YouTube live for this exam run. Yeah? So we're going to be kicking off with some tips, some tricks, and ultimately work out some problems. Yeah? All right, so give me 1 second. I'm going to do some formality here. Give me 1 second. 1 second, people want to text me. All right. Okay. Now let's get into it. Now, first thing for tips and tricks. For the exam, please. You guys need to understand that this is a battle. So please fight. What I mean by that is when you see problems, you try your best to write back your equation. Yeah, you might get a little point for that. Yeah, so you write back your equation. Speed equal distance over time. A squared plus B squared equals C squared. And then you try your best to use it as best as you can. Yeah. So writing back equations are good. Labeling your graph. Yeah, so when they ask you to label and plot something, put the Y, put the X. What is on the Y? Is it speed? Put him on there. Is he in miles per second squared? Is this guy time? Put him down there and then go do your plots. Yeah, make sure to label and then put a scale. What is your scale that you use for plotting that graph? Yeah, so please, people, label the graph now. Yeah, it helps. It goes a long way. CXC is looking out for these, and these. Yeah? I don't know how much marks them give, but at least if it's a 5-mark question, at least I think it's like 2 or 3 out of the 5 marks. And then the others is for the plotting actually correct. Yeah? So please label your stuff. All right? When CXC asks you to what's the word again now? Reflect this object here, and it's a object P, and he's located here. And I said to reflect him in the y-axis. Yeah, so y-axis is my mirror, and the mirror and the image can pop up over here. Please label it as, if this is B, label it as B prime. Yeah. And then put in the same dots and the same thing. So remember what a reflection is. It's going to pop up on the other side. Don't? Yeah? So please, when you're doing reflections, if they ask you to, they say, put the image on the diagram below, right? And label it B prime. Go label it B prime, please. Right? And then suppose them say them want this guy to get rotated in, and then it can pop up down here and it's going to be called B double prime. Please put the B double prime and go label your points and then go do what they want. Answer what CXC asks you to do. Please. All right. So that's another little tip there to make sure that you cement marks. Don't assume they know whatever you draw is is the answer. Yeah. When you're working out problems, say for example, I work out one of these problems, it's a good practice to just put answer equal to blah, 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 blah. You have your working in between, You have your working, But just make sure so you kind of underline your answer. Make it very clear, as crystal clear, what is your answer for the question. Yeah? All right. For these questions here that ask, hey, what's the largest integer value? I need to see a little statement that says the largest integer value is equal to blah, 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 blah. Yeah? Answer directly what they ask for. Please and thanks. Yeah? Let's go again now. What else could they ask me for? I'm just going to look for things that I've seen with students that is just, as I said, it's just all about like really being purposeful about your getting your marks. You get me? We're hunting for marks. We're not going to just give us. All right. I'm not seeing anything else. All right. Something like this, which is an inequality, right? And they're asking you to do, what did they ask you to do? On the graph above, action item, draw the line, this, and this. So don't gloss over that. Go plot the line. Yeah. So when I plot the line, I don't know how I'm going to look, but I'm going to look something like, something like this. I don't know, I draw something that is not him. No, that is not him. But yeah, go plot the line. I'm gonna try again, I'm gonna try again. Boom, 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 and boom. This is the line here. Me already plot him already. Yeah? People will ask me, how do I plot it so fast? It's because I'm doing it in my head. Yeah? So y equal to x minus 1. We're going to put x is 1. And then I'm going to then say, what is y? Y is going to equal to 1 minus 1. I'm putting this and updating it in the relationship. And then I get 1 minus 1. So y is 0. This is going to reveal to me the coordinate. X was 1. X always comes first. And then y comes second. So that is where I get this point here. So how do I plot a line? I have to use the relationship. And I'm going to update it with the independent variable, the x. And once I do that, I can go find what is the y. So x is 2 now. So we'll say x is 2 now. So then y is going to equal to 2 minus 1. Come here, replace anywhere we see x with 2. And then I can find what the y would have been. What's the coordinate? Coordinate needs two things. I have my x first, and then I have my y second. So x is 2, y going to be 1. So that is how I'm plotting the line really fast in my head, people. Yeah? So then x is 3 now. So as we said, we're moving along the x-axis because x is the input. He is the domain of this function. He is what comes into the function. Y is what comes out of the function. So y equal to x minus 1. I'm going to say, no, x is 3, people. So all I'm doing is, if x is this, y going to be that. If x is this, y going to be that. I'm going through each scenario. Yeah? So y is going to be now 3 minus 1. So y is going to equal to 2. So what did I say? When x is 3, 3 comes first, because that's x coordinate comes first, y coordinate comes second. Y going to be 2. That is how you plot lines, people. Yeah? So all I'm doing here is that I'm basically, in fact, my line kind of deviate a little bit of what it's supposed to be. But it's supposed to be, these are the points. Once I do that, people, then we just draw a line through all of those points that I've plotted. And that would reveal the line y equals to x. In fact, let me just erase everything. I'm going to make it a little bit more cleaner. Boom, 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 boom. No. Boom, boom, and boom. Yeah? So the tip here when you're plotting lines, right? Please, just calm down and just realize it's a relationship between y and x. Put in a x, you get back the y. Put in a x, you get back the y. Simple as that. That is how you plot a line. So CXC said, draw the line this. You know what they say? I never just draw a random line in what me ever feel, I don't just draw a line like that. Yeah, I have to draw it based on the relationship that they have given me. Y equal to x minus 1. Okay. Then them say shade the region that satisfies these inequalities. So they want us to shade where would be the region that satisfies that. In fact, I'm going to extend my y equal x minus 1 down to here and down to here. Yeah. So that is a full line that takes up the whole space, right? Now, for some people, let's kind of go through it. Yeah. So really and truly, I'm not even going to go through this one actually. That's just a plotting a line type of like a thing there. Let's go through some more tips as we go through. So first tip was what? Write out the equation. That's your guide. So if a squared plus b squared equals c squared in Pythagoras, write him first. Then go identify your a. Then go identify your b. Let's go use him right now. Let's go here now. What did this CXC tell you right here? This is let's say the diagram below shows a right angle triangle. Trigger alert. When it's a right angle triangle, all my students are supposed to know is a Pythagorean will reign true or SOHCAHTOA will reign true. Only them two things then. Yeah? Dimensions within x. Alright? So then now we'll say, okay, they said for the right angle triangle, show that this is equal to 0. I don't see nothing like that in here. I don't see nothing like that. So I don't know what to do. So a lot of students will tell me, say them stuck. No. What do you know is true for right angle as a trigger? A squared plus b squared equals c squared. At least write that now and get a little 0.5 mark. Right? Because this is true for a right angle triangle. And you have a right angle triangle right here. At least write something. Yeah? But I need you guys to fight. Not lay down and say, oh, this hard. That is your emotional state. I need you to calm down and realize that there's some problems. Yeah? So it's either you're going to apply yourself or you're going to just get 0. So just apply yourself. Now, when I'm saying that now, at least get a half mark doing that. Yeah, partial mark. Then now, if you want to take it further now, you'd start to think and say, well, typically, if this was a regular number, right, say 18, and this was a regular number, say 13, I would have identify my A, B, and C and plug them in here. So then, just because then give you X, it's like you get nervous. I don't have time for that. So then them say, wait, how do I identify the hypotenuse? He's one opposite of the 90 degrees. So that's my C, or my hypotenuse. So then change him now. So we know that C is this. So anyway, you see C, you can change him to 2x plus 3 all squared now. Anyway, well, my students should know, I don't care where you put the A and the B. That don't really matter to me. As long as you get your C correct, the A and your B can be anything. So I can put that A and this is B. So A is this, so that's x squared now. Because A is equal to x. B is what? 12 squared now. So I'm put that there. Let me know if that makes sense. Right? So then now, if you even reach to this stage, when I tell you, if anybody know this, you're supposed to know this about me. Well, if you see something squared, you can't do anything with x squared. X squared is x squared. But with 12 squared, you can actually go find it. 12 squared is 12 times 12. Go find it. 144. Right? So I'm putting in 144. Cool. Now, something you guys should all know, if I have an expression squared, like x plus 1 squared, yeah, it's the same thing as if I have 3 squared. Squared just means take the base and multiply it by himself. So squared means take the base and multiply him by himself. So x plus 1 times x plus 1. That's all it means, right? So don't get nervous because something look different, right? So this 2x plus 3 all squared. It means take the base and multiply him by himself, right? And then now we learn how to expand our brackets. First with the first with the second. And then we'll rinse and repeat, meaning that we're done with the first now, you know. So now we're going to get to the second. And he's going to multiply with both of them, just like how the first one did with both of them. So let's go step by step. 2x times 2x, that 2 times 2 is 4. X times x is x squared. 2 times 3, that's 6. And then put back the x. 3 times 2x, 6x again. That's this guy times this guy. 3 times 3, that's 9. Everybody knows, combine what looks similar. X squared can't combine with x. They're two different things that people, right? X can combine with x though. So this is 4x squared plus 12x, x plus 9. Yeah? So even if you reach to this point, good job, right? At least fight. So this is what, 4x squared. That's all I'm saying. I'm just trying to appeal to everybody to fight. Stop just being like, oh, this hard, I'm gonna stop. I want to cry. Stop that, man. Yeah? Fight for the marks and then take it step by step. All right? Okay? That's all I'm saying to everybody. Okay? So then now, where am I going to go with this? I don't know, you know? I don't know. It don't look like the answer. Right? I don't know what happened to the graphics on this thing. Yeah, let me try again. All right, there we go. All right? So then now we'll go again. I will say, okay, we have all of this. At least leave that. At least fight. Yeah? So now let's go through. Now, they said everything equal to 0. So that's an indirect way of saying everything is going to be moved on one side. So then I'm going to say, okay, I'm going to minus x squared over here. What I do to one side of the equation, I have to do to the other. So I'm minus x squared over here. So then this one, the goal of that was to remove him over here. So him pop up over the other side. So then now 144 equals to 3x squared plus 12x plus 9. Yeah? So what am I going to do next? I don't know. But I'm going to keep on making everything equal to 0. So then I'm going to move this 144. Him gone now. And I'm going to move him over here. So this is going to be a minus 144. Yeah? Now that's 0 equals to 3x squared plus 12x. 9 minus 144. What is that? Push a calculator. 135. Yeah? So minus 135. Yeah? Now, I've reached to a stage where I'm like, okay, I'm good. But no, it don't look like this, does it? But then I asked myself, well, can I divide everything by 3? Because I need the constant here to be 1. So if I divide this by 3, it makes it 1. But I can't do it to just one thing. I have to do it to everything. So if everything get divided by 3, What does that give me? 0 equals to x squared plus 4x minus 45, which is what they wanted you to show. Yeah? So please, take your time, fight for the marks, take a step, and try. So what I'm saying here, everybody should know, for right angle triangles, your triggers are things you want to make sure you have like your first thing you draw for. Pythagorean theorem is the first thing. Second thing would have been SOHCAHTOA. Why did I not use SOHCAHTOA here, everybody? Why did I not use SOHCAHTOA? I was not given any angles. No angles were given to me. That's the trigger for when you use SOHCAHTOA. When you're given all the lengths, your trigger is you're going to be using Pythagorean. Typically. Yeah? There's always exceptions to the rule. Hope that makes sense. So we'll learn how to label. Label your graphs, label any drawings that you're given. When you transform and transpose, make sure you label it. So if it's B over here, and him look like this object, and you transform him over here and him expand or enlarge, call him B prime when you're doing your labels. Write the equation. We just saw the Pythagorean in action just a while ago. Yeah? So, and then also when you're answering questions, I need everybody to make sure you are saying to them the length of, answer the exact question, the length of yx is equal to, after you don't do your work up here, say the length of it is equal to whatever it is right here. And then don't forget your units. If you've seen people forget them units too much, let me put it in bold. Don't forget your units. Yeah? Your units. Right? So label, equation, don't forget your units so far. Right? Okay? Now let's see what else we can do. Let's see if we can get busy with this guy here. Alana and that person shares a certain amount of money. Yeah? In the ratio of 8-7. When you're giving ratios, people, you notice that they give Alana come first, and then Brenton comes second. Alana, then the semicolon, then Brenton comes second. So this part of Yasa are for Alana. This part of Yasa are for Brenton. Yeah? Show that Alana receives this amount of money. Okay? Now, once you deal with ratios, make sure you understand something. So Alana over here, Brenton over here. This is the ratio. Then I tell students, hey, this is the ratio version. So if this is the ratio version, I need you to go find the fraction version for me, please. So then Alana would be getting 8. Out of how much? 15. I'm going to add both of them. Yeah? That's the 15 is the total of Alana and Brentnall. Yeah? Right? It's a total of both of them. So how much is Alana's portion out of the 15? 8 out of the 15. Just like probability, people, which we're going to see later on today. Okay? Then Brentnall, his is going to be 7 over 15. That's his fraction. Then if you look back on previous live streams, I talked about fractions. I talked about percentages. How do we use both of them, people? You don't just have a fraction, people. You have a fraction of something. So the total that they're sharing is 17,004. So if I'm going to find out how much dollar amount Alana have or Brent now, I'm going to apply Alana's fraction to the total amount. So this is me applying it, means I'm multiplying it. That's right. That's applying it would multiply. I don't know if it rhymes, but please take it away with me. Yeah. This is to get Alana's share. Yeah. So to use fractions or percentages, you have to multiply to the total. Yeah. Do the maths for me. This is a fraction multiplying with a fraction. Yeah. And then now it's up to you. If you're already if your maths, can I tell you, say, 17,400 can be divided by 15, then you're correct. 15 can go into 15 one time, 15 can go into him, and push the calculator is 1,160. Then how do I multiply fractions? Top times top, that gives me a number. Bottom times bottom, that's going to give me a number. Right? So then I'm going to do that. So it's 9,280 divided by 1. I don't want you to leave it like that though. 9,200. What is 9 divided by 1? No 9. No 10 divided by 1. No 10. Any number divided by 1 are the same answer, same value. So 9,280. Don't forget for show you're working. Show. So you have to show all of your working. I don't want nobody to tell the examiner say 9,280 without showing all of them calculations. Yeah? So that is Alana share. No, I'm going to be extra, you know. I know that's Alana I'm going to solve for. Come on, everybody understand it. So Brent Null, this is his ratio. Don't forget, when you have your ratio, you can convert him into his fractional version. When you have his fraction, you can go and find his dollar version after that. We're going to apply the fraction onto the total again, 17,400. Yeah? 15 can go into 15. I'm going to simplify early. 15 can go into this guy, and I will get 1160. And that's going to give me 1160 times 7. I push my calculator. Give me 8,120. That's top times top. Bottom times bottom will be 1 times 1. That gives me 8,120. So remember here, when you do this though, I like to tell students, go check your work now. I don't want nobody tell me say it might be right. When you add this to this, don't you get back 17,400? So that is telling you that you have broken it or split up that total amount into Alana as Britnell's share, where Alana gets more because her fraction bigger, because her ratio bigger. That is how you're going to check your work as you go through. Because you see, when me done math exam, me never ask no question if it right or wrong, you know. You get me? So I want everybody to have that power too, where you realize, oh, that makes sense, you know, because Britnell ratio is smaller, so you must get less of the money, right? So I hope that makes sense. All right, that's a little ratio check there. All right, let's go. Ready, set, go. Let's go. What else? Now, Alana invests her share of the money. What's her share of the money? What's her share of the money? 9,280. So I'm teaching my students, listen, when you read slowly, when you make the thing come alive, don't just read it and then read all the way to money and then wonder what the heck you just read. Read it slowly, put together the whole story. So of 9,280 into the business venture, earning simple interest, trigger alert, simple interest. What did we learn about simple interest long time ago? Simple interest have one formula, right? So you see, for this problem, at least write back the simple interest formula, no? Yeah? So then simple interest would equal to what? I equals to PRT. Some people would have learned I equals to PRT all over 100. Make I use this version because what you do is in another live stream where I showed you this way can be actually easier for you. All right? Now, how much is she investing? 9,200, 9,280. So that is your P. That is how much she's investing. That's how much money she's putting up into this business venture. That's her principal. Yeah? Simple interest at a rate. They tell us the rate now. Yeah? A rate is 4.5%. But for this version of this, we have to make this a decimal. Yeah? So remember 4.5%? Percentage just means throw the number over 100. Yeah? My students should learn, wait, when I divide by 100, 2 zeros, move it 2 places to the left. Or go push a calculator, whichever one quicker. So 0.045 is the rate I'm going to be using. Yeah? So 0.045. For this equation here, if you're going to use it for simple interest, make sure the rate is in a decimal format. Decimal. Okay? All right. Now, so I have a P, what have a R? What else we need? She receives 2,088 in interest. So they give us the interest. Read it, people. Read it. It says interest. Don't? So then there must be interest. Yeah, so that's 2,088. Determine the number of years that she invested the money. So then when you know that a letter is equal to something, that means that once I start off with my guide, which is supposed to give you like a 0.5 mark, then I can change my things to what they're equal to. I is 2,088. P is 9,280. R is 0.045. And T, I don't know him. But you can't be doing an equation and not have anything to solve for. So that's the thing that we're going to solve for. Yeah? So then now, any number times any number must give you another number. So push your calculator. So 9,280 times 0.045 gives me, that's a nice number, 417.6. And that times t gives me 417.6 t equals to 2088. Yeah? Then I'm solving for t here, everybody. So if I'm solving for t, it's just like 2 times x. That's a 2x, sir. 2x equal to 10. How am I solve that? Well, I need to, this is my left, this is my right. I need to solve so that x is by himself. So what do I need to remove from the left? The 2. What's the 2 doing? He's multiplying, sir. How do I remove him? I'm going to divide, sir, because that's the opposite of him. That's how you remove him. What I do to the left, I have to do to the right and balance. So x equals to 5 now. If you can do it for the basic case, we can do it for the not so nice looking ones. So 417.6 t equals to 2088. I need to get t by himself because I'm solving for time, number of years. What do I need to remove from this right-hand side? The 417.6. What action is he doing to the t? He's multiplying, sir. So I'm going to divide, sir, to get rid of him. Yeah? So if I divide here, that's the right-hand side. I have to balance and divide it over here. Everything in math and life is about balance. If you do it to one side, you have to do it to the other. Right? So 2088 is going to be divided by that amount. That gives me 5 years as my time. Yeah? And you lock up your 2 marks there. Okay? So that is for the simple interest problem here. So I hope that makes sense. That's ratios, that is fractions, and that's applying it with simple interest. Yeah? Let's go again now. What else triggers can we do? We're going to go through another one that has to do with angles. So let's kind of go through that one. I don't know where it is on this past paper. It's somewhere here. Boom, this guy. So some grade 2 students were surveyed to determine the job sector in which they are most likely to seek employment after graduating. Okay? Their choices are represented in the pie chart below. So these are the different options that some grade, I'm assuming these are grade 11 students. This can't be grade 2 students, grade 11 students, right? Yeah? So these are the different career choices that they're thinking about. Yeah? And so remember here, people, I'm not ever going to do things and just read it straight to the problem. I want to try and understand what's going on here. So I'm splitting up all the interests. Yeah? Okay? Now I noticed that some of the interests are represented as angles. And some of them have variables, 2p, 3p, 4p. Yeah? So I'm like, okay, all right, that's cool. Now, they want us to calculate the percentage of students who are likely to seek employment within the agriculture and ICT sectors. So I look at the agriculture, I see 40%, and I see ICT, that's 67%, right? They want what as the answer here, everybody, right? Not percent, sorry, 40.5 degrees, 67.5 degrees, right? They want the percent of students, yeah? And so how are we going to find the percent of students? That's kind of the question that you have to ask yourself here, right? Now, I can find the total amount in terms of angles for agriculture and ICT, yeah? That looks like it's going to be 108 degrees. That's the degrees. How can I translate that to percentage? Well, they're sharing an entire 360 degrees. Yeah? So for me to find the percentage, I'm just going to put this percentage over the total degrees. And that's going to give me the actual, percentage of the total interest that actually chose agriculture and ICT. So then I'm going to get 0.3. To make that into a percentage, I'm going to multiply it by 100, which makes it 30%, which would be here. So I hope that makes sense. Yeah? So make sure we understand what just happened. We're given interest based on, we wanted agriculture and we wanted ICT. Yeah? So I grabbed what is the total amount of degrees that these guys was allocated for these guys. That's 108. I did 40.5 plus 67.5 and I got this. Push your calculator if you need to. Right? Okay. Then now they don't want degrees though, people. They want a percentage. So I have to think to myself, this is the amount of the whole entire interest, which is 360 degrees. So angles in an entire circle add up to 360. So then I will then put that over 360 and multiply it by 100. That's going to give me the percentage. All right. Okay. Now, the next one that I knew was coming is calculate the value for P. So sometimes I see students would say, well, I don't know what P is, sir, because I see P and this. No. What did I just even talk to you about? Angles that form an entire circle add up to 360 degrees. Let's go step by step. Let's say that again. Angles that form an entire circle add up to 360 degrees. One more time. Angles that form an entire circle add up to 360 degrees. So that means if you add this angle with this angle, and you add it to this angle, and you add it to this angle, and you add it to this angle, and this one, it's supposed to sum up to 360 degrees. Stop saying it in words now. Write an equation that results in that. So that means that this angle, which is 90, plus this angle, 67.5, plus this one, 2p, plus this one, 3p, plus this one, 40.5, yeah? All right, let me give myself a little more space, right? Plus 4p must equal to 360 degrees. So when you learn some things, and you learn something like angles on a triangle add up to 360, you want to list out the angle them in the triangle and then set it equal to 360. Form an equation. We need an equation. That's the only way you're going to solve for the value for P. So then when we're solving equations, we learned combine the like terms. So number can combine with number. So 90 plus 67.5. Then we're going to grab the sign in front and the object and move him. So all the numbers are together. Then we're going to grab the sign and the object and all of the P's are going to be together. Sign in front and the object. Sign in front and the object. Yeah? And move him back equals to 360. So now that I have all of my numbers together, I can combine them and get one number here. So then now, I'm going to push my calculator. 67.5. I don't know why I'm doing that, but I'm going to do it again. 198. And then all of the letter them supposed to add up to one value down here. 2 and 3 make 5. 5 and 4 make 9. Equals to 360. What you don't use, bring it back down. What you don't use, bring it back down. Now I'm solving for the value for P, people. So that means I need P by himself equal to something. So then I ask myself, hey, sir, tell me, so this is the left, this is the right. Where's the P? He's on the left-hand side. What do I need to remove from the left-hand side? The 198 and the 9. Which one you want me to remove first? Well, sir said always remove the add and subtract first because it make your life easier. If you move the 9 first, you have to create fractions when you do that. We don't want to do that. So we want to save the multiply, removing the multiply for last. So I'm going to subtract 198 because he's adding. What I do to one side, I have to do to the other. So then my updated equation is 9p equals to 360 minus 198. That looks like 162. Okay, hope everybody's checking with me. Yeah? So remember the goal of that step was to remove the 198 from the left-hand side. So on the left-hand side, you should not see 198 anymore. Yeah? Then now I want to solve for P. So I ask myself, what do I need to remove? The 9. What's the 9 doing? He's multiplying, sir. So I am going to divide in order to get rid of him. Remember, the goal of that step is to remove the 9. So in the next step, you're not supposed to see the 9. You're supposed to only see the P. So 9 cancel and remove him. What you do to the left, you have to do to the right. That's how you solve equations, right? Yeah. So then that's the P equals to 18. That is the value for P. And that will give you your 3 marks there. Okay. So I hope that's making a lot of sense to everybody in terms of how to tackle certain things like that. You have to form some sort of equation. Yeah. All right. Now, how we're going to wind down today, we're going to wind down with the second part of this. This is January 2026, everybody. And that's why I'm just kind of like, let me just knock it out quickly so that everybody is up to speed. Now, let's talk about probabilities with each other. So let's see what is happening here. All right. So Liz has a set of red and yellow and white buttons in a sack. She chooses a button at random. Okay. So what is a probability, by the way? Anybody know what's a probability? Yeah? What's a probability? A probability is a chance of something happening. So let me kind of be very visual here. Suppose I had 2 calculators and I had 3 phones. Yeah, I put them in a bucket. Yeah, so they're both in a bucket. All of them in a bucket. All 5 objects are in a bucket. Yeah, what's the probability of me if I put my hand in there without looking at it, right? Selecting a calculator, right? Well, there's 2 options of what I could grab out of the 5 things that are there. That's the probability. That's the chance that I pull a calculator. Yeah. What's the probability that I pull a phone? Well, there's 3 phones in the bucket out of the 5 objects that are in the bucket. That's how you find the probability of me pulling a phone. Yeah. So that's what probability is in a nutshell. It's a chance of you doing an action or pulling something based on how many things are inside of there. So typically you put total at the bottom and you put the number of objects matching your criteria at the top. So if I want calculator, that calculator, that is the criteria I'm after. How many calculators we had there in the bucket? 2 of them. So there's a number of objects matching your criteria. Matching criteria. Okay. Now let's see if I can hammer through these. The probability that she chooses a yellow button is 0.3. The probability she chooses a white button is 0.1. Now, another thing about probability is that probabilities should add up to 1. Probabilities sum up to 1. Yeah? So remember here, she's choosing a button. This is the chance she gets a yellow. This is the chance she gets a white. Well, there's 3 different buttons in there. So what's the chance you get the other thing then? Yeah? So that's what I would want you guys to think about. Yeah? So probabilities add up to 1. So the chance that the probability she gets a red, plus the probability she gets, P is for probability by the way, P is for probability. Probability she gets a yellow, plus the probability she gets a white is all going to add up to 1. Remember people, always formulate some sort of equation. Yeah? That's how you're going to solve things. Yeah? Now, they gave me the probability she gets a yellow, so I can change him to 0.3. They gave me the chance that she gets a white. That's 0.1. Put back down what I use. And then that will help me to get and solve the probability she gets a red. So then, probability she gets a red plus 0.4, because these are numbers, they can combine with each other. That's it. So probability she gets a red is going to equal to 1 minus 0.4. Probability she gets a red is 0.6. Yeah? Because every chance that she gets any of these buttons, right, they must all sum up to 1. Because she has the possibility of getting all of those 3 options, right? That's what you want to kind of make sure you understand. So probability she gets a red is 0.6. So write that down somewhere. I don't even want to look at the questions as yet. I want to make sure someone understand the actual question, right? So probability, she chooses a red button is 0.6. So they didn't give me that information, but because of my knowledge of probability, I know that she can get a yellow, she can get a white, but can't she get a red also? Yeah. So that means that there is a probability for red also. Go find it. Yeah. Determine the probability that she chooses a red. Oh, well, there we go. We answered part 1. We answered part 1. There we go. Yeah. So, all right, let's go. If there's 80 buttons in the sack originally, determine the number of buttons that were red or yellow. Okay. So we found number 1 already. That is 0.6, right? Because the total sum of probabilities add up to 1. Now, there's 80 buttons in the sack. 80 of them, you know. Yeah. Determine the number of buttons that were red or yellow. All right. Now, how would we apply this now? So first we can find how much are red. Yeah. Because 60% of any total amount would be red. 30% of any total would be yellow. 10% of any total would be white. So then that means that if they gave me 80 buttons, 80 times the 0.6 would give me the number of red buttons. Yeah? 80 times the 30 would give me the number of yellow buttons. Yeah? 80 times the 10%, 0.10, will give me the number of white buttons. So go find them. Yeah? So 80 times 0.6, that looks like 48. I think that's 48. Check my maths if I'm wrong. Because 8 times 6 is 48. Yeah? 8 times 3 is 24. Yeah? 8 times is just basically, what's that again? 60, 72, 8. Yeah? So when you do that math, you're going to get that. Yeah? So they want to know, determine the number of buttons that were red or yellow. So I'm going to grab how much are red and I'm going to add it to how much are yellow. That's going to give me how much buttons are either red or yellow. So that will give me 72 when I do 48 plus 24. Yeah, it gives me the 72. So that is a gist of probability. Probability just has a chance of something happening. Yeah, and so I hope that makes a lot of sense to everybody. So let's go over that one more time. There's 80 buttons, but when you look at probability, I need you to realize that probability and percentages are used hand in hand. So this is the chance of me getting a red button, which is also the percentage of me getting a red button. So that means that if they change this, suppose them change the problem, and then they didn't tell me 80. They told me 120 buttons are in there now. Why don't they answer the question? So now we're going off tangent now, so we can actually learn what's going on. 120 buttons in there now. Remember here, 60% of that is going to be red. So then, for the total, I'm going to apply 60%. And I get whatever that is. That is 72? Think so, right? I think the math says 72. Let me just check myself, because I don't really want to show the wrong thing. Yeah? Right? 30% of them are yellow. So this is the red buttons. Okay? So once again, this probability is almost like how we did percentages and fraction. It after get applied means multiplied to the total. Just like with percentages and fractions. You don't have 20%. You don't have 1/2. Yeah? That don't make no sense. You have 20% of something, so it have to get multiplied to something. You don't have 1/2. You have 1/2 of something, so it have to get applied to something. Yeah? So that's what I'm saying to you here. Probability are the same way, just like those. So 60% or 60 is the probability. So that means that 60 needs to get applied, multiplied to the total. That's going to reveal the number of objects that are that. So this was the probability of red button. This is going to give me the number of red buttons. Yeah? So 120 times 0.3, that will give me the number of yellow buttons. Because I'm applying the chance onto the total. Right? Probabilities, percentages, and fractions need to get applied to a total. Yeah? That looks like 36 when we do the maths. Yeah? Then 120 times 0.1, this is the number of yellow buttons. Right? And then 120 times 0.1, that will give me 12. That's the number of white buttons. So I hope that's making a lot of sense. That's a theme I wanted to kind of close off with in terms of how to apply percentages, how to apply probabilities, how to apply fractions, how ratios are, remember we did the ratio problem earlier, right? Ratios translate into fractions, and fractions are applied to the total. That's how I'm going to get the number of anything that I want. Yeah? So that's the theme for today. I wish everybody good luck for them exams. Go apply yourself. Yeah? Reach out if you need any help. You know how to get in contact with us. It's been a pleasure. Welcome to Your Actuary Tutor JA, and we'll be back next semester in September. All right? Okay? Wish you guys the best. Go